Welcome to the group exhibit Hydrogen Fuel Cells and Batteries at the Hanover Fair 2017. We are here at the Technical Forum and my name is Muriel Burkas. Please have a seat, join us for the upcoming presentations. We have some free coffee and free drinks. I would also like to give a warm welcome to our guests watching the presentation online through our live streaming. And let's start with the next presentation of the afternoon. It will be regarding approaches to catalyst and reformer testing, the NOVOROCS Fuel Processing Test Station. Please welcome with me on stage the Technical Director of NOVOROCS Technologies, Dr. Phillip Hutton.
Thank you, thank you. My name is Phillip Hutton. I am Technical Director of NOVOROCS Technologies. Right now I'm going to give a short presentation on our newest product line. It's and what I'll go over is basically how we came to develop it, initially for NASA and subsequently for universities and small R&D companies. The title of the presentation is Approaches to Catalyst and Reformer Testing on NOVOROCS Fuel Processing Test Station. Before I go over the presentation, I want to give you a little bit of background on NOVOROCS Technologies. NOVOROCS Technologies is a US-based company. We're located in Rochester, New York. We were founded in 2013. NOVOROCS is a joint venture between Solid Cell and Unicat. Solid Cell is a solid oxide fuel cell company. And as a solid oxide fuel cell company, they have a lot of experience with designing reformers. Unicat is a catalyst company. As a catalyst company, they have a lot of experience with fabricating catalysts for different types of fuels. It's a natural marriage. And so NOVOROCS has core competencies in catalyst design and fabrication, reactor design fabrication, and testing and commercialization. So what do we do? This slide gives some products we've made for customers within the last couple years. In the upper left-hand corner, you see a tail gas combustor. You can actually see this in person at booth D37. And this was developed for Team FAST, a student group that is developing a fuel cell bus engine. And they want to run the fuel cell on formic acid. And when they run the fuel cell on formic acid, they have to run it in an open-ended configuration. So the tail gas on the anode has some hydrogen in it, and they needed a way to combust the hydrogen. And what this does is it takes that hydrogen, runs it through a catalytic combustor, and then it takes the heat from that combustion process, and it recycles that heat back to the front end, the reforming end. If you look in the upper right hand, you see a pilot scale steam methane reformer. We developed this for a fuel cell company. It's the front end of a hydrogen purification system designed to produce hydrogen for refueling stations. If you look at the bottom right, you'll see catalytic combustors. That's what's one of our core competencies. We custom design catalytic combustors for companies and universities. And we're real excited about our metal foam catalyst. The metal foam supports, provide better heat transfer, turbulent flow, and good surface area. What I'm going to talk about today are the test benches, and that you'll see that in the upper middle picture right there. And I'll go over how we developed it and why we're excited about it as a new product line. This was initially developed for NASA. NASA is actually investigating the prospect of dropping solid oxide fuel cell power systems on Mars prior to the arrival of astronauts. They want to drop a small 5 kilowatt system on Mars with liquefied methane and a little bit of water. And so they want to take that methane, a little bit of water, run it through a reformer, make syngas, run the syngas through the solid oxide fuel cell system, and then take the tail gas from the solid oxide fuel cell system, condense out more water from the tail gas, and use that for subsequent operation, subsequent running on the fuel. They did some initial testing. They had some trouble with their initial catalyst. They had some trouble with their reactor system. And so they actually put out a request for a test station and for a metal foam catalyst that was right up our alley. And so we got the gig. What you're seeing here is the actual test station we developed for NASA. What the test station does is it takes water, it runs the water through a pump. The pump then applies that water through a mass flow controller so you can meter out the water into the actual reactor. We also use cylinder gas. We run that through mass flow controllers so you can meter the methane into the reactor. In the reactor, and you'll see this on the right-hand side, both the gas and the water go through preheat coils. The water is evaporated and then preheated up to the temperature we want it to be, and so is the gas. One of the unique features of this are the fact that the flanges are at both ends are flanged, and they stick out outside the furnace. And what this does, it allows NASA to replace the catalyst and do multiple runs on the actual reactor. If the flanges were inside the furnace, they would seize up at the temperatures that we run at. So after we made this for NASA, we received several inquiries as to whether we could actually build this for a university. And so we decided to do just that, build a turnkey product for universities at a very, very good price. Some of the key features of our fuel processing test station, we use a multi-purpose reactor, very similar to the NASA reactor that you saw in the previous slide. This allows you to do steam reforming, partial oxidation, and allothermal reforming. We use a split tube furnace, so this gives you easy access to the actual reactor. It allows you to make any changes on the fly while you're to open it, view the reactor while you're doing testing, and actually make changes afterwards very, very easily. Of course, it has preheat coils. It has a condenser that allows you to cool down and condense the water out of the reformant. Water flow control, gas flow control, and most importantly, it's very economical. The typical price point for a fuel processing test station is between $60,000 and $100,000, where our base model starts at $20,000. So we feel that this is a very, very attractive price point for a fuel processing test station. Now, applications. Given the price point and the versatility and the mobility of the actual test station, we feel it's ideally suited for universities, for teaching, for laboratories. You can use it for catalyst testing. If you're demonstrating products, like let's say a fuel cell, you want to demonstrate the fuel cell on syngas. You can produce syngas with this system and run that into the actual fuel cell. So you don't need cylinder gas for that. And it's also good for prototype testing if you're testing a power system and you want to test it on actual syngas. I want to thank you for taking the time to come here after lunch. If you're still hungry, we have a catalytic grill up there. We use, as I said, one of our core competencies is catalytic combustors. So we have a catalytic grill that's combusting some propane, and we're grilling some hot dogs in booth D37. Please feel free to come and visit us. Thank you.
Thank you very much, Philip.
you.
Are there any questions from the audience? Not yet. Everybody still has food in the stomach. I would like to know, you mentioned the price, and it's much cheaper than the common.
Yes, it is.
How comes?
Well, because we have the experience, we don't automate things we don't have to automate, and that's one of the reasons why this is a great teaching tool. Because a lot of times, students, when you have an automated test station, all the students really learn is how to push the buttons. You know, it's all theory. When you actually turn the dial and you watch something happen, you get a better feel for how you control flow, how you control water. And so we make sure that we keep it as simple as possible, and we bring the price point down because we don't make a huge profit. We don't expect this to be our bread and butter. We expect this to be a side product, unless obviously unless we're wrong, which would be nice. But so you know, but we're not going to make a living on this one, you know. But it is going to be a product that we hope to sell.
Great. Thank you very much for your second presentation this week, Philip. The booth, if you want to discuss the topic later, is D37. Please pass by, have a look. If you missed the presentation or if you joined later, everything will be up on our website, available to watch it again later on these days. Thank you very much. The next presentation will only start at 1:40 p.m. today. It will be with Dr. Ulrich Schmidtchen, board member of HiSafe, regarding the topic hydrogen safety is drivers for public acceptance. See you in about half an hour again. Enjoy a break. Stay with us, have some coffee, have some drinks. It's all for free. Thank you very much.